calculated based on the orientation angle of different points. The point is here, and the magnitude of the stress is beside that. So in your handout also is the same thing. The magnitude that you see is beside the point. It could not be on the point. So you have these values. You calculate the stresses because you apply 100 kPa under the foundation. You also have 100 kPa pressure. As you go away from that and in the vertical direction, the pressure reduces. So with the equation that you have, it's not possible to calculate the contact pressure under the foundation. You need to set it up. And then you use equation. See that even here I set up an equation for sediment calculation. That's the initial values. That's based on Pi. The initial stress, that's the average initial stress you transfer to pore water pressure. So the initial pore water pressure is equal to Pi, and you have it there. This value, in a way, is total final sediments because it's calculated based on Pi. All right? That Pi is going to dissipate from the system and become zero. When it's equal to zero, you get the sediments. That would be, Pi would be the change in the effective stress. So I calculated that first, and then at any stage, if you go down here and select a point, you find that it's connected or linked with some of the points at the top. So you like to calculate pore water pressure at this point, at the point corresponding to here, and the values used is for the points around that. For any other point, like just take this point. So for this point, you use values of the point around it. And therefore, at each time step, now the time step is calculated based on beta. I set beta of 0.25. You have the option of using any value of beta less than or equal to 0.25. If you use beta of 0.25, the calculation becomes simple. So I have at time 0, at time 0.125, now it could be year. It depends on the unit that you use for CV. Because the different values are set up for you, you could get a very small value for CV, you can change it. Instead of having meter square per year, you can change meter square per second or minutes and so on. But be clear in your drawings and in your answer. Give the dimension for the time, for example, when you ask for. So we go down at time 0.25. Again, the only thing that I've done is I copied the whole lot here many times. You could use other method, but I copied it. So I copied many times, each time because the different cells are linked to the previous cell on top of them, then you could have them calculated automatically. So the only thing that you set up well at the beginning is one is the initial condition for the soil and pore pressure, calculate the sediments here, and the next step based on final difference equation. And here, if you look at the equation for sediments, that's consolidation sediments. If you look at this, it says that C27 minus something. That C27 is up there, this value. That's the total final sediments minus the contribution due to the pore pressure that you have there. So that's the total final sediments. When pore pressure here becomes equal to 0, then you get the sediments equal to the total final. So at the beginning, the sediment is very small, but you see that gradually it increases with time. And finally, I had calculated the consolidation sediments this is the variation of pore pressure with time and variation of sediments with time. All right? On one side we have pore pressure, on the other side we have consolidation sediments. And that's time, in my case, is in year. you could have it in minutes or seconds, something which you could really draw it. But one point to consider is that you see pore pressure, when pore pressure is equal to 0, you get to that much sediments, that's the total final sediments. In your case, it says that calculate the time required for 90% of consolidation and 50% of consolidation. Make sure that you get to the final point here. If you like to calculate time for 90% consolidation, first you need to have total final sediments multiplied by 0.9 to get 90% of that and find the time corresponding to 90% sediments. If you don't reach to this flat portion of the curve, then the answer that you provide will be wrong. You're asked to calculate pore pressure sediments, the time corresponding to 90% sediments and time corresponding to 50% sediments, or what's the total final sediments, what's the sediments at time at the particular time. Another thing is that you need to provide the soil profile when sediments is at 50% or 90% and so on. So at that particular time you need to draw it. And make sure that when you draw variation of pore pressure and sediments with time, you use logarithmic scale. If the scale is not logarithmic, you won't see that flat bar. And I'm not sure if I can do that here. I'll show you. If not logarithmic, then what you see here is it seems that it's flat, but definitely around this point is not. You cannot find the time when final consolidation occurs. So make sure that you draw it in a logarithmic scale. Other information like variation of sediments, that's the soil profile, that's at ground level. And the time after 1 year, 2 years, 25 years, and so on. And you see that after 1 year, the soil swells a little bit and settles later on, but gradually with time the soil profile goes down. Anything else? Can also play with
没听懂怎么这样。
I think Modco doesn't work with this computer, but
you need to enable the network.
yeah. Anyway, in this case, we're trying to show you the variation of pore pressure in X and Y direction with time. And these are variation of pore pressure with time at the middle of the layer. That's variation of sediments with time. And at the particular point of, I think the time is now, say maybe 20 seconds, you have this variation of pore pressure. At the base of the layer, you have the maximum pore pressure, and under the foundation, you have the maximum one. As you go away from the foundation and come closer to the surface, when you have free boundary, the magnitude of pore pressure reduces. So here, the pore pressure is equal to 0. All right? Before I forget, in the boundary condition that you select, you see that this value here corresponds to a point here, this value corresponds to a point here, and this value corresponds to a point there. At the corner of the foundation, the point is free draining, is permeable boundary. So at the corner of the foundation, the pore pressure must be set equal to 0. Can I borrow your iPad? So in your assignments, you have a flexible strip footing. That's on page 94 with a width of B. It's resting on the surface of the soil. In your case, it's highly jointed bedrock, so it's permeable. Which is at depth of 2B. The soil has a Young modulus of E, given as a function of your student number. It's the last 4 digits of your student number. It's in KPA. So the last digits of your student number. And I'm hoping that none of you has
0, 0.
0, 0, 0, 0 in absolute. If you have, just email.